Hello all, I am Disha Shukla and welcome to the session. In this session, we are going to discuss about antenna and propagation. Now, an antenna is a device that is used to transmit or receive electromagnetic waves. Electromagnetic waves are often referred to as the radio waves. Most antennas are resonant devices which operates efficiently over a relatively narrow frequency band. An antenna must be tuned or matched to the same frequency band as the radio system to which it is connected. Otherwise, reception or transmission will be impaired. That is, whenever you don't match the frequency band, the transmission and the reception will not be equal. That would not be paired, it will be impaired. Now here you need to understand two terms called as directivity and gain. Directivity is the ability of an antenna to focus energy in a particular direction when transmitting, or to receive the energy better from a particular direction when receiving. There is a relationship between gain and diversity. We see the phenomena of increased diversity when comparing a light bulb to a spotlight. Now see, whenever you are using a light bulb or a spotlight, the amount of light that you get differs. Say for example, a 100-watt spotlight will provide more light in a particular direction than a 100-watt light bulb, and less light in another direction. We can say that the spotlight has more directivity than the light bulb. The spotlight is comparable to an antenna with increased directivity. Gain is the practical value of the directivity. The relation between gain and directivity includes a new parameter called efficiency. So, gain is equal to efficiency into directivity. Now moving forward, what is an antenna gain? An antenna gain is a power output in a particular direction compared to that produced in a direction by a perfect omnidirectional antenna that we saw when we gave an example of the light bulb and the spotlight. And what is the effective area? So related to the physical size and shape of the antenna, the effective area of a particular antenna can be defined. What is antenna gain and how is the relation between the effective area? Say here the antenna gain is G and is equal to 4 pi AE upon lambda square, that is equal to 4 pi f square upon c square. The lambda is divided, that is your bandwidth is divided into frequency divided by the speed, so that becomes f square upon c square into AE, where G is your antenna gain, AE is your effective area, F is the carrier frequency, C is the speed of light, and lambda is the carrier wavelength. Radiation pattern. Radiation pattern is the term used to represent the emission or reception of the wavefront at the antenna, specifying its strength. In this illustration, the sketch drawn is to represent the radiation of an antenna in its radiation pattern. One can simply understand the function and the directivity of an antenna by having a look at its radiation pattern. The power when radiated from an antenna has its effect in the near and the far region. Graphically, radiation can be plotted as a function of angular position and radial distance from the antenna. This is a mathematical function of radiation property of the antenna represented as a function of spherical coordinates E of theta and omega and H of theta and omega. So radiation pattern is the energy radiated by an antenna is represented by the radiation pattern of the antenna. Radiation patterns are diagrammatically representation of the radiation of the radiated energy into the space as a function of direction, that is, in which direction the amount of energy is radiated, that defines the radiation pattern. Now as you can see here, the figure shows the lobe formation. In the representation of the radiation pattern, we often come across different shapes which indicate the major and the minor radiation area, by which the radiation efficiency of the antenna is known. To have a better understanding, consider this figure. Here, the radiation pattern has main lobe, side lobe, and back lobe. The major part of the radiating field, which covers a large area, is the main lobe or the major lobe. This is the portion where maximum radiated energy exists. The direction of this lobe indicates the directivity of the antenna. The other part of the pattern where the radiation is distributed sideways are known as side lobes or the minor lobes. These are the areas where the power is wasted. And there is another lobe which is exactly opposite in direction to the main lobe. This is called the back lobe, which is also a minor lobe. A considerable amount of energy is wasted even here. So this is about the radiation pattern, how the radiation pattern occurs and what are the different lobes, etc. Moving forward, types of antenna. Now, antennas can be of different types based on their direction of transmission, the way that is, if they are transmitting in a single line or they are transmitting in omnidirection, based on that. So the first one is the isotropic antenna. Now, an isotropic antenna is an ideal antenna. Whenever you are comparing the efficiency of a particular antenna, it is compared to the ideal antenna. That is, you compare the efficiency of an ideal antenna to the antenna you want to define. So the ideal antenna is something that radiates the power equally in all the direction. The next is the dipole antenna. There you have two types, that is half wave dipole antenna or quarter wave vertical antenna, and the last one is the parabolic reflective antenna. This can be more clear when you go through the figure. The first is the whip or the monopole. It works best for the narrow range and can be collapsible. These are mainly used on the small radios and the vehicles. The second is called the Yagi. It is ideal for the long distance directional application. It can reach multiple frequencies. The third one is the dipole. Now here two monopoles facing away from each other are placed, and it is used to generate a powerful signal in restricted space. The fourth one is called a loop. It looks like a dipole and reaches multiple frequencies. It is commonly used for TV and RFID systems. The next is called the Bowtie, that is another type of a dipole. Here the angles can be set to work well with the different frequencies. The last one being dish. Here the large surface space reflectors collect a lot of signals, and it works well for a high frequency TV and sound. So this is all about what is antenna gain, how its efficiency can be measured, what are the different radiating patterns, what are the different types of antenna, and which type of antenna is used where. If you are not clear with this text, you can contact me. Until then, keep learning.